Welcome to Astronomy Daily, your daily dose of the most fascinating developments in space science and astronomical discoveries. I'm Anna, and today we're exploring some incredible stories from across the cosmos, from the ongoing search for water on Mars to a cosmic cloud that looks surprisingly like a running chicken. Stay with me as we journey through today's biggest astronomy headlines and try to make sense of our vast and wonderful universe. Let's kick things off today by diving into something huge. I'm talking telescopes so powerful, they'll redefine how we see the universe. Let's explore the findings of a recent National Science Foundation, or NSF, report on the U.S. Extremely Large Telescope program. Now, what's this all about? Well, two telescopes are in the spotlight, the Giant Magellan Telescope, or GMT, and the 30-meter telescope, or TMT. These aren't just any telescopes. They're set to be game changers in the world of astronomy. So, why are these telescopes such a big deal? For starters, they'll allow scientists to tackle some of the biggest questions out there. How did galaxies form? What exactly is dark matter? And, wait for it, are we really alone in the universe? The GMT and TMT are designed to work alongside other international projects, like the European Southern Observatory's ELT. Together, they'll give us the clearest, most detailed views of the cosmos we've ever had. Now, let's talk about what the NSF report revealed. The good news is that both projects are scientifically superb. They're uniquely capable of delivering insights no other telescopes can. But there's always a but. They need more funding to keep moving forward. We're talking about $1.6 billion. Without it, the projects could face some major setbacks. And that's not the only challenge. There are also technical hurdles and the tricky task of coordinating multiple partners worldwide. The report says the projects need solid risk management plans to make sure things stay on track. Here's another cool part. These telescopes will do more than just look at the stars. They'll also help train the next generation of astronomers. Picture this, a pipeline of early career scientists getting hands-on experience with some of the most advanced tools in the world. Amazing, right? And on top of that, there are plans for public outreach. That means more educational programs to inspire all of us Earthlings to look up at the night sky and dream big. So, what's the takeaway? The NSF report makes it clear. These telescopes are absolutely critical for keeping the U.S. at the forefront of astronomy, but their future hinges on securing that funding. Will Congress and the scientific community step up to the plate? Only time will tell. But one thing's for sure. If these telescopes come to life, they'll take our understanding of the universe to dazzling new heights. Next up, let's turn our focus to the red planet, where the search for liquid water continues to challenge scientists. A fascinating new paper published in the Proceedings of the National Academy of Sciences has cast doubt on our hopes of finding liquid water on Mars, at least in the forms we've been looking for. More than a century ago, astronomer Percival Lowell captivated the world with his theory that Mars had canals built by intelligent beings to transport water from the polar ice caps. While better telescopes eventually disproved this romantic notion, the quest to find liquid water on Mars has remained one of planetary science's most compelling pursuits. The challenge lies in Mars's harsh environment. With its frigid temperatures, thin atmosphere, and minimal water vapor, any liquid water would quickly freeze, boil, or evaporate. Scientists have been particularly interested in features called recurring slope lineae, or RSLs, dark streaks that appear on Martian slopes during warmer seasons and fade in colder ones. While these seemed promising, new research suggests they're likely just flows of sand and dust, with no water needed to create them. Some researchers have turned their attention to brines, solutions with high salt concentrations, as potential sources of liquid water. Mars has plenty of salts, and some, like perchlorates, can remain liquid at incredibly low temperatures. For instance, calcium perchlorate brine only freezes at minus 75 degrees Celsius. Given that Mars's average equatorial temperature is minus 50 degrees, this seemed promising. However, the new study, led by Vincent Chevrier, who has spent 2 decades studying Mars, concludes that even these brines face significant challenges. The relatively low amounts of promising salts, combined with water vapor pressure and ice location, severely limit the possibility of stable brines on or near the surface. And even if such brines did form, they would be extremely inhospitable by Earth standards. Despite these sobering findings, the search continues. Scientists are now focusing on developing better instruments to detect small amounts of brines and identifying more promising locations to look for them. As Chevrier notes, while Mars remains a cold, dry desert, the possibility that some form of life could have adapted to these extreme conditions keeps the search for water alive and relevant. Now, a quick China update. In major developments from China's commercial space sector, launch startup Landspace has secured an impressive 900 million yuan, that's about $123 million, in funding from China's National Manufacturing Transformation and Upgrading Fund. This substantial investment is earmarked specifically for developing and testing their new line of reusable methane-powered rockets. This funding comes at a crucial time for Landspace, which recently achieved a significant milestone with the successful launch of their enhanced Zhuke-2 rocket. They've also completed a promising test of their more ambitious Zhuke-3 launcher, managing a 10-kilometer vertical takeoff and landing at the Jiuquan spaceport. The Zhuke-3 is particularly interesting. We're looking at a massive stainless steel rocket that stands nearly 77 meters tall. When it's ready, it should be able to lift an impressive 21,000 kilograms to low Earth orbit in its expendable configuration, or up to 18,300 kilograms when recovering the first stage downrange. Landspace is aiming for its first orbital launch in 2025, with plans to achieve first stage recovery and reuse by 2026. This development is part of a broader trend in China's space sector. Since 2014, when the government opened space activities to private investment, we've seen numerous startups emerge. Other companies like Space Pioneer and Orionspace have also secured substantial funding this year, highlighting China's growing commitment to commercial space development. What's particularly noteworthy is that Landspace has also announced plans to begin launching cargo missions to the Tiangong space station by 2026. This represents a significant step forward in China's efforts to commercialize its space operations and potentially compete with established players in the global launch market. A fascinating new image has just been released from the European Southern Observatory's Very Large Telescope in Chile, giving us an incredible view of what's known as the Running Chicken Nebula. Now, I know what you're thinking, a cosmic chicken? But wait until you hear about this remarkable celestial formation. Located about 6,500 light-years away in the constellation Centaurus, this emission nebula officially goes by the rather less colorful name of IC 2872 or GUM40. But once you see it, you can't help but notice its uncanny resemblance to a chicken with its head tilted upward, as if wondering about its place in the cosmos. What makes this image particularly striking is how the nebula's features align to create this whimsical shape. In the lower right, you can see what appears to be the chicken's head, complete with a bright region of star formation that looks just like a glowing beak. Dark clouds extend upward from this area, forming what looks like a pea comb on top of the chicken's head. The science behind this celestial spectacle is just as fascinating as its appearance. As an emission nebula, it's essentially a vast cloud of ionized gas that produces its own light. The intense radiation from nearby stars energizes the gas, causing it to glow in various colors depending on its composition. We can spot numerous young, bright blue stars scattered throughout the image, including one that perfectly marks what appears to be the chicken's eye. This cosmic bird has quite a history in astronomical catalogs. It was first documented back in 1888 by Danish astronomer John Louis Emil Dreyer, and later included in Colin Stanley Gumb's 1955 catalog of emission nebulae in the southern sky. It's a remarkable reminder that even in the vastness of space, we can find shapes that feel somehow familiar and even playful. For those of you who received a telescope this holiday season, Sky and Telescope have published a list of useful tips for getting the most out of your shiny new toy. So let me share some of their essential tips to help you start your stargazing journey on the right foot. First and foremost, resist the urge to rush outside immediately. Take time to familiarize yourself with your telescope indoors, where you can comfortably learn how everything works, from adjusting the mount to changing eyepieces. Once you're comfortable with the basics, try your telescope during daylight hours. Practice focusing on distant objects like treetops or buildings. This is also the perfect time to align your finder scope, which will be crucial for locating objects in the night sky. Remember, your lowest magnification eyepiece will give you the brightest, sharpest views and the widest field of view, making it easier to find your targets. Now, what should you look at first? The moon is an absolutely spectacular target for new observers. Even in a modest telescope, you'll see incredible detail in its craters, mountains, and valleys. The best views come when you observe areas near the terminator. That's the line between the moon's day and night sides, where shadows really bring out the surface features. The planets are also excellent targets right now. Jupiter is particularly impressive, showing its cloud bands and 4 brightest moons even in small telescopes. Saturn, despite its rings being nearly edge-on this year, still offers an unforgettable sight. Venus is currently visible as a bright evening star, showing phases similar to the moon when viewed through a telescope. One crucial piece of advice: be patient. Many newcomers expect Hubble-like views, but remember that most astronomical objects appear subtle and gray to the human eye. The longer you spend observing an object, the more detail you'll begin to notice. Also, don't feel disappointed if things look a bit blurry at first. Atmospheric conditions play a huge role in telescope viewing, and some nights will be better than others. Keep in mind that astronomy is a journey of discovery, not a sprint. Take your time learning the basics, and you'll be rewarded with views of some of the most amazing objects in our universe. For these and more tips, I'll include a link in the show notes to the original article. And that brings us to the end of today's journey through the cosmos. I'm Anna, and thank you for joining me here on Astronomy Daily. If you'd like to learn more about any of our stories or get the latest updates in astronomy, head over to our website at astronomydaily.io. You can also be part of our growing community of space enthusiasts on social media. Find us as Astro Daily Pod on Facebook, X, Tumblr, YouTube, and TikTok. There's always something fascinating happening in the universe, and we'll be here to share those stories with you. Until next time, keep looking up and wondering about the mysteries above us. This has been Astronomy Daily. I'm Anna, signing off.